Step 7, describing segments. In this step, we are reusing again the segment solution we obtained in section 5.5.4 using the vacation motif dataset from the package FlexClust, and where we extracted a 6-segment solution. The first thing we want to do is we want to extract the cluster assignment of each of the respondents to one of the 6 clusters. We're doing this by using function clusters and applying it to the cluster object vacmod.k6. This returns a vector of length 1000 containing numbers from 1 to 6, and we can tabulate this to see how big are each of our segments, for example. And the next thing we are doing is we're coercing that integer vector into a categorical variable using the function sFactor, and we are adding it as an additional variable to the data frame vacmod.desc, which contains the descriptor variables. And what we want to do now is we want to use these descriptor variables which have not been used for extracting or creating the market segments to further, in a way, characterize the segments. And we want to see, do segments differ with respect to some of the descriptor variables. First, what we want to look at is can we visualize? Is there an association between segment membership and nominal or ordinal descriptor variables? And first, what we are looking at is there a difference in the gender distribution. So for this purpose, we're creating a cross table between the segment membership and gender. These two variables are contained in the data frame vacmod.desc. So we are evaluating that expression, which creates the cross table, using the data frame vacmod.desc, and this is indicated with the function with. So this gives us this cross table. This is a 6x2 table because we have 6 segments and 2 categories for gender. And this contains the absolute frequencies. So now we want to visualize it, and what would be a first idea of visualizing this could be to use a stacked bar plot. So on the x-axis we have the segments, on the y-axis we have the number of observations assigned to each of the segments. So the height of the bar gives us the size of the segment, so we can compare easily these segments and see that segment 5 is the smallest one. And within the segments, we split it in a dark and a light gray area. And the dark gray area, the height represents the females, and the light gray area, the males. So we could look at the absolute frequency of females and males within each of the segments. But what's the disadvantage of that stacked bar plot is because the overall size differs, we have a problem in comparing the proportion of females within each of the segments. And to simplify this comparison, a mosaic plot can be created. We are using both dimensions because here, in some sense, the dimension of the x-axis is not used. The width of the bars doesn't convey any information, and this is improved by using a mosaic plot. Let us zoom into that plot. So here at the bottom now a mosaic plot was created, and we see that the segments here, they differ also in the width now, and these have been created in a way that the width is now proportional to the segment size. So we can again, if we compare the length here on the x-axis, we see segment 5 is the smallest one. What we have on the y-axis is the proportion of males within segment 1 compared to the proportion of females. So we can easily see here that in segment 2 the proportion of female is highest because this bar is higher than any of the other bars. Length times height, the area is proportional to these absolute frequencies we had in our original table. So that's why the mosaic plot is a better visualization than a stacked bar plot. Here we have used mosaic plot. That's the function for creating a mosaic plot, where we put in the table and we didn't want to have a title, main equals the empty string. We have used shade equals fold. Let us now look at what does the mosaic plot look like if we put shade equals true. Now the areas are unchanged. We only see that the borders have changed. And we have now this legend with standardized residuals. And in some sense, if all of these are white, we have no indication that there is an association between gender and segment numbers, which means that the proportion of females is approximately the same over all segments. Let us look at another example. If we can find other descriptor variables where there are differences in the distribution of the descriptor variable between the segments. And we can do this using, for example, the income variable. We create the cross table between component, segment membership, and income. We use shade equals true. And we get this mosaic plot. So again, the width are the same of the bars because this is the segment sizes, and what we can then see is what does the income distribution within each of the segment looks like. And we now also have areas which are either in light red or light blue, indicating that there is a small deviation of what we would expect if there is no association. So this is a segment which contains very few respondents with a very small income, whereas segment 4 contains a lot of respondents with very high income. And we can also do this for moral obligation to see if the segments differ in their moral obligation level.